Hi, Sally. Sally, I was trying to find my presentation and I have no idea where that is at. So I'm just giving you some screenshots of how you can set this up for your kids to see and make it kind of a game where they're going to see patterns and magic squares and things like that. And of course, emphasize to them the only reason why we use tic-tac-toe over here is when your A coefficient is not equal to 1, it's greater than. Because other than that, you just do your factors of C whose sum equals B, and that's just a straightforward factoring. But what I do is I have these examples up here that I've given, 5 examples, and I just write them, and I ask the kids, can you see a pattern? And it usually takes them maybe a minute, 2 minutes, and they try to see what relationship these four numbers have with each other, 10, 5, 2, and 7. And they finally figured out that the two inner numbers, when they multiply, equal the top, and the two inner numbers, when you're added, equal the bottom number. So 5 times 2 is 10, and 5 plus 2 is 7. And that pattern continues for all of these, I think. Double check. I'm hoping. But that is probably the hardest part to do for tic-tac-toe. And what we're asking them to do is to be able to list all the factors. But down here is their check. 5 times 2 is 10. 5 plus 2 is 7. And I did that for each of those. And you could just put those on the board one at a time or a bunch of them at a time. And now for the next page, here's the other skill that they need for tic-tac-toe. The second skill they needed to factor is using the GCF, or the greatest common factor. And what I ask them is to take a look at these two numbers, 2 and 10, and what is the greatest common factor between 2 and 10. And I see that I made a big, huge mistake here. I don't know what I was thinking, except my dog is here. Between 2 and 10, the GCF is 2. Between 3 and 9 is 3. Between 7 and 21 is 7. And between 12 and 4, the GCF, I did it again. Golly, what is wrong with me today? It's been that way all day long. I'm glad I'm going over this and fixing this so when you see it, it looks better. The greatest common factor between those two numbers, of course, is 4. Now then, going down here and looking at it, are you marvelous at listing factored pairs? Now this next piece, that's the GCF. And the third part about tic-tac-toe is figuring out factor pairs. So if I'm looking at 12, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Factors of 8 are 1 and 8, 2 and 4. I teach my students to list factored pairs starting with the smallest factor and increasing, and then when they start to repeat, you're done. So if they're pretty good about listing factors of the numbers, then we are good to go for tic-tac-toe. So we're ready to put the pieces together. Sally, I realize this is going to look really squirrely the first time you see it, but like I told the students, once you see something 7 times in a row, our brain just clicks in, and generally they're just fine with it. I can't factor any other way anymore, so I'm bad. But here you go. How to factor by tic-tac-toe. This over here is your map. The first thing you do is you draw a tic-tac-toe grid. The second thing you do is you look at your equation and you tell the students about A, B, and C, those constants that are so important for us. Coefficients and constants, and I put them in each specific spot. A, C, and then A times C. Go in those places. And what we're going to do is fill the edges in first, all the way around the box like this. And we're going to end up making a magic box, kind of like a Sudoku, except it's multiplication. But over here, the next one, this is where your factoring process comes in, and that first page of do you see a pattern. I want factors of AC whose sum equals B. So we're going to put those two numbers in the middle, and what this is, those are those 4 numbers that we had on the front page. So top, middle, and bottom. So I want factors that I can multiply to get AC and then add them to sum that equals B. This looks kind of like garbage right now, and I just added it in there to let you see what we're going to be doing. This piece right in through here is your magic box. We're going to do greatest common factors in this common square between this one and this one. We put it in that common square. And the greatest common factor between this column and this row goes here. And then you move on the inside, but I don't even treat that as a greatest common factor. I think of it as a magic square, and I will show you next how it all works. Okay, here's our first example. We're looking at 2x squared plus 11x plus 12, and you remind the students that A is 2, B is 11, and 12 is C. And you load it in the tic-tac-toe grid. 2, 12, and the AC is 24. Now I want factors of 24 whose sum is equal to B, which is 11. And of course that would be 3 and 8. So I load those two right in here on the tic-tac-toe grid. Okay? Then over here, next part 2 will be greatest common factor between 2 and 3. The greatest common factor between 2 and 3 is 1. The greatest common factor between 2 and 8 is 2. And I put those GCFs here. Now you can skip the GCF if you want to. This just becomes a magic square. I want to know what number times 1 is equal to 3. And you can also do GCF here. What's the greatest common factor between 12 and 3 is 3. But it makes a true factor pair. 1 times 3 is equal to 3. And then the GCF between 12 and 8 is 4. But again, it makes a true statement. 2 times 4 is 8. And this is your checkbox. And this is why NCTM likes this, because the students, if they check their work and make it a true square of factors, then they will not get their signs mixed up with the negatives and the positives. So here we go. 2 times 1 is 2. 4 times 3 is 12. 1 times 3 is 3. And 2 times 4 is 8. And so that's your little magic checkbox. All the inner in that square will equal the edges. I've probably totally lost you right now, but here we go. Once the kids calm down, they really do like it. Now that's you're done. Honestly, this is totally new. I better put is in there for you. This is totally new to most of you. If you work 7 in a row, you will have mastered it. And that's because that's what psychologists say. If you have new material, you need 7 to 10 times. So now then, how do I find it? Here's where your factors are buried in that really cool magic square. This one right here, the orange, if you say, and the x's are always in the first column. So coefficient of 1x plus 4, and then the coefficient of 2x plus 3. And there is your solution set. And basically, this is what it should look like. When the kids get really good at it, that's all you'll ever see. And next page, here we go for practice. And I've made a bunch of gobbledygook over here. The simpler, the better. But I'm just trying to show everything. 3x squared plus 14x plus 16. This is a good example of why we would do tic-tac-toe. When these numbers are so big and they're weird, you don't see it right away. So all you have to do is load in A, C, and A times C, and that's 48. Okay, factors of 48 whose sum equals 14, which is B. So 1 and 48, 2 and 24, 3 and 16, 4 and 12. Well, the one that equals 14 is this one right here, 6 and 8. And I load them in 6 and 8. Order will not matter on this, just haven't put it in. Now we're looking at the greatest common factor between column 1 and row 2 on the endings. So I want the greatest common factor between those two numbers. Greatest common factor is 3. The greatest common factor between 3 and 8 will be 1. Now then, you're going to ask yourself, because this is blank, what times 3 is equal to 6, or you can do the greatest common factor, but I just like to do the multiplication across. 3 times something would be 2 is 6, and what times 1 is equal to 8, that's equal to 8. Let me show you over here kind of what it would look like. Let me see if I can get my pen to work on this. Here we go. You are now at this point. We have 3 and we have 1. We have 6 and we have 8. And all of these, kind of all the way around on these, always make magic squares. And you're asking yourself, what times 3 is 6? 2. What times 1 is 8? 8. And those will be the greatest common factor between 16 and 6 and 16 and 8. So you can GCF it or just ask them what number would make a true statement. But at any rate, once you've done that, we'll go back over here. That big loop right here, 3 times 8 is 20, 3 and 8 is one pair, and 1 and 2 is another pair. Again, the first column is the first number inside each parenthesis. So 3x plus 8 times x plus 2. Now, number 2 is where we start to really use tic-tac-toe with the magic box, because I've got negatives. You load them in, A, C, and AC. So 2 times negative 15 is negative 30. What factors of negative 30 can I add together and get negative 7? You can have them listed, or they can just think of it, but here are all the factors of 30. And I just list them again in order, and there it is, the difference of 3. And you will usually find that this one right here, if it's negative, it is always going to affect the larger factor if you list it this way. But there you go, negative 10 and 3. So I load those in here. Now then, greatest common factor, square right here. Greatest common factor between 2 and negative 10, between 2 and negative 10 is 2. And the greatest common factor between 2 and 3 is 1. Now, what times 2 is equal to negative 10? Negative 5. Or, what is the greatest common factor between 15 and 3 will be 3. But 1 times 3 is 3. 1 times 2 is 2. 3 times negative 5 is negative 15. 2 times negative 5 is negative 10. 1 times 3 is 6. So we've checked that magic square box. I should be able to multiply and get the correct output all the way around the box. So here you go. You make your nuclear fallout sign or your orbit. 2x plus 3 and 1x minus 5. And I think I gave you a few more examples here. And this, again, it looks very nice and neat once you get it down. A, C, and A times C. So I'm looking at factors of 21 whose sum must equal 10. And that would give you 7 and 3. Now, greatest common factor between 3 and 7 is 1. The greatest common factor between 3 and 3 is 3. So now you can just say, these will be blank. What times 1 is equal to 7? 7. What times 3 is equal to 3? 1. And I just fill in the boxes. And I'm not sure that this it's better when I'm teaching this in the classroom and I'm writing this. I should have just written it while I'm talking. But again, you would have had 1 and 3 here, and over here was 7 and 3. You just ask yourself, what times 1 is equal to 7? What goes in that missing box? What times 3 is equal to 3? 1. And now you're done because your answer is buried right there. 1x plus 1 and 3x plus 7. And here are the bigger numbers, and this is where the kids, especially older students in high school, realize the potential for tic-tac-toe is when I have really ugly numbers. How are you going to factor that? Well, you're going to load in 4 times negative 17, you get negative 68. You list your factors for 68, you just start listing them. And I'm looking for the difference between the two factors of negative 32. The sum of the factors have to equal b. And there it is right there, 2 and negative 34. I'm going to put the negative with the larger factor if the very first sign you see is negative. So now when I multiply negative 34 times 2, that does equal negative 68. And then 2 plus negative 34 is equal to negative 32. Now your greatest common factor between 4 and 2 is 2. The greatest common factor between, again, 4 and 2, 4 and 2 and negative 34 is going to be 2 again. So what times 2 is equal to 2? 1. And what times 2 is equal to negative 34? Negative 17. So there is your orbit. You're looking at 2x minus 17 and 2x plus 1. And here are some more examples for you. I think I gave you 5. Did I give you more than that? Nope, sorry, just gave you 5. I had all of this typed up so the kids had a worksheet, and I will try to find time this week to do that again. But I'm hoping that this helps. It looks more complicated than it really is. But if you'll set it up in little pieces like number 1, can they see a pattern written on the board? That's a secret. And then on this page, can they find greatest common factors between 2 and 10, 3? And you'll notice how I tried to put them on at an angle, but you don't have to do that. And then how can you list the pairs so that when you multiply or sum the difference, sum them and you get B. Okay, Sally, I hope that helps. But tic-tac-toe, once they get it, if you'll do, I'm not kidding, if you'll do 7 of those, they will get it. And they really do enjoy it. But if they have, tell them that, of course, this only works with whole number, integer factors, and we use it particularly when A is not equal to 1. But that's NCTM for you. Take care and thanks.